Hello guys, you're welcome back to my channel Fun with Physics. In today's lesson, we are going to be looking at the explanation of density. The topic is actually from our textbook, Complete Physics for Cambridge Secondary 1, Unit 8.9. Now, without wasting time, we quickly go to what we have for today. Now, why are solids so dense? Do you have an idea why solids are so dense? Now, let's look at the particle theory here, what we have here. We have solid, the particles of solid, how they are arranged, the particles of liquid, how they are arranged, and then of gases. Now, from particle theory, we know that solids are closely packed and vibrate about a point, like what we have on the screen. Now, liquids slide over each other. The particles or the molecules of liquid slides over each other. Okay? And then gases move randomly, colliding with each other. This is what we are used to, isn't it? Good. Now, solids are so dense because they have more particles tightly packed in a given space or volume, let's say in 1 centimeter cube, more particles than liquid and gases. That means they have more matter in them, or more mass as the case may be. Now, they have less space between particles than liquids and gases, like what we have here. We have less spaces here, right? Now, where we're supposed to have space here, we have electrons filling up those empty, or those supposed empty areas. Okay? They have less space between particles than liquids and gases, and then their molecules are arranged in an orderly fashion or manner, the way what we saw in the last in this slide. Okay, while these ones are arranged in orderly manner, these ones are not. These ones are free to move randomly about. Okay, density does not just depend on the arrangement of particles. We cannot just say because the particles are packed. It also depends on the mass. No, we cannot just say the particles are of fixed arrangement, fixed shape, but it also depends on the mass of the particles. Okay? At constant volume, densities are directly proportional to the mass. That means when you have more mass, more matter, we expect the density to be higher. But when we have less mass or less matter packed in a given space, we expect the density to be what? Lower. Now, aluminum, for instance, has a mass of 2.6 gram in 1 centimeter cube. Okay, but gold has a mass of 19.3 gram in the same 1 centimeter cube. So in that case, we can say it's more dense, or it's denser than aluminum because it has more mass, right? Water, on the other hand, has a mass of 1 gram in just 1 centimeter cube, so it's less dense than gold and aluminum. Okay, so the number of matter you have determines, in a given volume, of course, determines how dense, okay, the object will be. Is that clear? Now, why do some things sink and others float? Can you figure out the reason? Objects will float when its density is less than that of the liquid that is actually put in. That's one reason, one condition. If, for instance, the density of a liquid is 1 gram per centimeter cube, and then you have a substance that has about 0.8 gram per centimeter cube in the liquid, that substance is going to float. Okay? Now, number two, if it has air spaces in them, like what you have on the screen here. Now, the bigger the air spaces, the better it floats. Okay? This is actually used in a lot of designs. Okay, designs of objects that move or sink or floats or sink in water. Now, where we have less space, airspace here, it floats not as much as when you have more space. And in this case, the last one here, where you don't have airspace, what happens? It sinks. Okay. Now the last one is if its weight is less than upthrust or maybe equal to upthrust. If its weight is less than or equal to upthrust, it's going to sink. It's going to float. All right. So let's say the weight is not as much as the upward pull of water. It's going to float. Are we good? Now, why is density important? Why do we need density? Of what use is it to us? Any ideas? Now consider 1 kilogram of steel and 1 kilogram of aluminium. Is there any way you can differentiate them? They look both the same, isn't it? Okay. Every element has its own unique density. So how could that help? How would that help? Density helps us actually to determine the material of an object. Like, now let's assume I melt gold and then copper and decide to combine both, an alloy, isn't it? Now, when I combine both, the density will not be the same as the density of a pure gold. Now, it can be able to help me to differentiate between which one is fake gold and which one is pure gold. Did you get that? Each material has its density. Iron, zinc, aluminium, they all have their different densities. So with their density, we can be able to identify. We can say this is iron for sure, this is gold for sure, this is silver, and so on. Okay? What's the proof that water and ice have different densities? Now, from what we have on the screen, what can you see about this having different density? Of course, ice floats in water, so we expect it to have a density that is less than the density of water. But why? Why ice is a solid and water is a liquid, but why does it have a density that is not as much as the water where it floats? Okay, it's solid but not doesn't have as much density as water. Can you explain that? I will leave that to you to think about and then come up with a useful explanation. Okay, your explanation should be on the comment section. Right, liquid layers. If you pour together liquids that don't actually mix and have different densities, they will form what is called a liquid layer. Liquids with the highest density will be at the bottom, and the liquid with the lowest density will be at the top. Object or substance with more density will sink below objects or substances with less density. Which do you think is more dense, water or oil? Which will float on which? What I mean is, will water float on oil or will oil float on water? Okay, guys, think about it and come up with an idea, right, of what will happen. But mind you, oil will float on water if it's less dense. Okay, if it's less dense than water. But if it's more dense, then it will sink. Did you get that? All right, if you have two or more substances, the more dense substance will be on the bottom and the less dense substance will be at the top. In this case here, we have like up to 3, 4, 5, 6, 7, 8 different substances, okay, in a container of different colors. We can see that this is the least dense and this one is the most dense one. Now here we have oil and olive oil and water. Okay, you can see that this one actually floats on water because it is less dense. It's giving us different layer, isn't it? water, oil, and a super ball. Now look at consider this case. We have a super ball, water, and then oil. The oil is less dense than water, so it's on the top. However, the super ball is less dense than water, but more dense than oil. It actually sinks to the bottom of the oil layer, okay, but doesn't sink any further. Okay, it actually floats on water but sinks in oil. So we have it at the bottom of the oil layer, right? Still on liquid layers, which liquid has the highest density from what we have here? We have oil, we have water, we have a golden syrup. Which liquid has the lowest density and which liquid has the middle density? Of course, oil here has the lowest density. Golden syrup here has the most density, is the most dense liquid here, and then the highest density, and then water has the middle density here. Okay, check out the picture. Which layer has the highest density? Which layer has the lowest density? Imagine that the liquid have the following densities: 10 gram per centimeter cube and so on. Which density would you give? Which density would go with which layer? Okay, let's see. We expect the least dense, the smallest density, which is 3, to go with this one, the least dense liquid, isn't it? Yeah. So the next one should be 5 gram per centimeter cube, followed by 6 gram per centimeter cube, and the most dense liquid will have 10 gram per centimeter cube. Okay, still on liquid layer. Imagine that the liquid on the right have the following densities. Now, these are the densities. Match the colors to the correct density. Can you do that? Okay, I'll leave that to you to try. You can figure out what to do from what we did earlier, like this. Okay? So match it correctly. Is that good? Is that okay? Now, guys, I want you guys to leave a comment at the comment section below. If you love the video, or if you don't feel you don't understand anything, please leave a comment. I'll get back to you soonest. If you feel there's things I need to fix or adjust, please leave a comment. Okay? Until we meet next time. Thank you.